Hi everyone, glad to see you again. Today I have something informative lined up for you. If you found this video helpful, don't forget to like, share and subscribe. Stay safe online cyber network. Before we dive in, let's set the stage for what you're about to learn. It's important to be clear. This discussion is intended solely for educational purposes and nothing more. Our focus today is to highlight a common web security flaw, aiming to raise awareness among both developers and everyday users who rely on the internet. By understanding how things can go wrong, we empower ourselves to build safer, more resilient systems. Learning from mistakes is the first step toward improvement. Please remember, never attempt to replicate any of the attack patterns or techniques described here unless you have explicit written permission from the system owner. Unauthorized access is not just unethical, it is illegal and can result in severe legal consequences, including fines or even imprisonment. This presentation is not a how-to guide for malicious activity. Instead, think of it as a guided tour through a digital crime scene, designed to help prevent future incidents by learning from past vulnerabilities. The vulnerability we'll discuss was discovered and reported responsibly, ensuring that no harm was done and that the affected parties could address the issue. Ethical hacking is about making the internet a safer place for everyone by identifying and fixing flaws before they can be exploited by bad actors. As you continue watching, keep in mind that our mission is to advocate for stronger digital defenses and smarter security practices. The internet is a vast, shared space, and each of us has a responsibility to help keep it secure for ourselves and for others. Let's move forward with this shared understanding and commitment to ethical behavior in mind. By participating in this discussion, you're helping to build a culture of security awareness, one where everyone plays a part in protecting our digital world. What is SQL injection? Imagine a website's database as a secure vault. To access it, you need to speak its language, SQL, structured query language. When you log in, the website builds a SQL command to verify your credentials. SQL injection occurs when an attacker tricks the website into running malicious SQL code. Instead of a simple username, they inject extra SQL code into the input box. This changes the original question the website asks the database. It's like tricking a librarian into giving you access to restricted sections. The database executes the command, unaware it's being manipulated. Suddenly, the attacker can access sensitive data or bypass security checks. This simple trick can lead to a full-scale data breach. It's a concept with devastating consequences. Let's explore the fascinating connection between website forms and the databases that power them behind the scenes. When you interact with a website, especially one that asks for your information, you're actually engaging with a complex relationship between the form you see and a powerful database working in the background. Every website is made up of two main parts: the visible front end, which is what you interact with, and the hidden back end, where all the processing happens. The front end is designed to be user-friendly, making it easy for you to enter information through forms, like logging in or searching for transactions. Meanwhile, the back end acts as the engine room, containing the application's logic and, most importantly, the database where all your data is stored and managed. This database is like a digital vault, holding valuable information such as customer names, account numbers, and transaction histories, all organized for quick access. The front end and back end are in constant communication, exchanging information and instructions according to a specific set of rules or scripts. For example, when you search for a transaction, the back end takes your request and constructs a special command called a SQL query to find the right data. The database then retrieves the relevant information and sends it back to the server, which displays it for you on the website. All of this happens in just a fraction of a second, making your experience feel seamless and instant. However, the back end often trusts the information it receives from the front end, assuming it's correct and safe. It expects a date when it asks for a date, a username when it asks for a username, and so on, without always double-checking. This trust can create vulnerabilities if the website isn't built with security in mind, leaving the door open for attackers. One common attack, called SQL injection, takes advantage of this trust by tricking the database into running harmful commands. That's why it's absolutely crucial to validate and sanitize all user input, making sure only safe and expected data gets through. By understanding how forms and databases interact, developers and users alike can help build and use more secure applications, protecting everyone's information. Let's work together to ensure our digital interactions remain safe, secure, and trustworthy for everyone. How does an attacker exploit trust? In the world of cybersecurity, attackers are always searching for weaknesses in the systems we rely on every day. Let's walk through a basic SQL injection attack, one of the most common and dangerous web vulnerabilities. It all starts with reconnaissance. The attacker carefully examines a website, searching for input fields, like login forms or search bars, that communicate directly with a database. The attacker then tests these input fields by entering unusual characters, such as single quotes or semicolons, to see how the website responds. If the website isn't properly secured, the database might return a detailed error message, revealing valuable information about its structure. This is a clear sign of vulnerability, like finding a key left right next to a locked door, inviting someone to try it. Next, the attacker crafts a special input designed to manipulate the database query, often using knowledge gained from the error messages. For example, entering OR1 = 1 in a login form tricks the database into bypassing authentication, since the condition always evaluates as true. The database executes the manipulated query, logging the attacker in without needing a valid password or credentials. From this point, the attacker can escalate the attack further, extracting sensitive data, modifying records, or even deleting information. They can reveal entire database tables, dump their contents, and access confidential information like usernames, passwords, and personal details. This attack works because the website blindly trusts user input, failing to properly check or sanitize what's entered. Proper input handling, validation, and the use of prepared statements can prevent these vulnerabilities and keep data safe. By understanding how SQL injection works, we can take proactive steps to protect our systems and prevent costly breaches. Let's work together to ensure our applications are secure, resilient, and ready to defend against evolving threats. Banking websites are prime targets for cybercriminals because they hold financial assets. A successful attack on a bank could lead to direct theft of funds. Banks store sensitive data like names, addresses, and transaction histories. This data is valuable for identity thieves and fraudsters. A breach can cause long-term damage beyond financial loss. Trust is crucial in banking. A breach can shatter it instantly. The cost of a breach includes investigations, notifications, and legal fees. Banks face attacks from sophisticated criminal syndicates and state-sponsored groups. SQL injection provides a direct line to valuable data, bypassing security layers. Finding a vulnerable banking application is like discovering an unguarded tunnel to the vault. Banks must invest in robust security measures to protect their assets. By understanding the risks, we can build stronger defenses. Let's ensure our financial systems are secure and trustworthy. During a security assessment, we found a flaw in a banking website's branch search feature. Instead of a zip code, we entered special characters, triggering an error. This indicated the input was passed directly into a database query without proper checks. We confirmed the search field was vulnerable to SQL injection. An attacker could exploit this to extract sensitive information. We didn't extract data, but confirmed we could execute commands. The potential impact was significant, risking customer data and privacy. A simple feature could have led to a full-blown data breach. This highlights how small oversights can create massive risks. We reported the flaw responsibly, ensuring it was fixed. No harm was done, and the bank's defenses are now stronger. This is the power of ethical hacking in action. Discovering a security flaw presents a choice misuse or responsible disclosure. Ethical hacking means reporting vulnerabilities to protect others. The process involves privately notifying the organization and working with them to fix the issue. It's about acting in good faith and using skills for the greater good. The initial report should be clear, explaining the vulnerability and its impact. Collaborate with the organization's security team to develop and deploy a patch. Give them time to address the problem before public disclosure. This ensures the flaw is fixed before exploitation by malicious actors. We followed this process with the banking website, ensuring no harm was done. The bank's defenses are now stronger, thanks to responsible disclosure. Ethical hacking helps build a more secure internet for everyone. Let's support and encourage this positive, constructive work. How can banks protect against SQL injection? The defenses are well known and effective. Never trust user input. Treat it as potentially hostile. Use prepared statements to separate SQL commands from user data. This prevents input from being mistaken for a command. Validate input to ensure it matches expected formats. Reject input that doesn't meet strict criteria. Practice defense in depth, using multiple security controls. Employ a web application firewall to inspect incoming traffic. Adhere to the principle of least privilege for database accounts. Conduct regular security audits and penetration testing. By implementing these measures, banks can protect their assets. Let's ensure our financial systems are secure and resilient. This banking website flaw is a reminder of our digital world's fragility. Security is a public safety issue, not just an IT concern. Insecure code can impact thousands, affecting financial security and privacy. Developers and organizations must prioritize security from day one. Secure coding training prevents vulnerabilities like SQL injection. Ethical hackers play a vital role in identifying and fixing flaws. Bug bounty programs and safe harbor policies support this work. Online safety is a shared responsibility for users and builders. We must prioritize security in everything we create. The digital world relies on trust. Fixing vulnerabilities reinforces it. Let's build a more secure internet for everyone. Together, we can make the digital world a safer place. Thanks for watching and learning with me. Drop a comment below if you have any questions or suggestions for future videos. I value your feedback. Cyber Network.